Hi friends, in this video we see analog and digital communication related questions asked in a TNEB AE exam. And I already have posted analog and digital communication related question asked in TRB. So this question may serve for that exam also, right? Let us see that. The first question is the pulse communication system that is inherently immune to noise. So it's a well-known direct question. So the pulse modulation which is highly immune to noise is pulse code modulation. So option D is a right answer. Okay. Next, one of the following communication system is digital. Right, we know that in AM is amplitude modulation. Here both carrier and what you call message are continuous, so it is not digital. In FM also same category. In PAM also same. So delta modulation we know it is a sample and whose difference is modulated. So it is a digital modulation. Next one, frequency shifting is widely used in telegraphy. Very, very important point, right? So we must know that in every concept, first initial concept is analog, then only it was made digital, right? But in communication engineering, telegraphy is digital in nature. Then only we developed AM, FM and all. Those are all analog in nature. Modulation and all have come later. So telegraphy was first invented, which is digital in nature, right? That is very important. A small point for remembrance. Okay, next one is which one of the following is used in TV broadcast system? We know in TV, we must remember in TV, audio is FM, video is VSB AM, right? So in video TV transmission, VSB transmission is widely used. Okay, and total bandwidth needed for 55.25 megahertz with 0.5 megahertz video modulation, right? So we know in video we are using AM signal they have given. For AM bandwidth is given by 2FM. Here what is the message frequency? FM is a frequency of the message. Here you see bandwidth required at 55.25 megahertz with 0.5 megahertz signal. So FM is 0.5. 2 into 0.5, that is 1 megahertz. So at 55, that 55.25, we have 1 megahertz bandwidth. That is the meaning, right? So option C is a correct answer. Next, okay, this is another important simple question. A transmitter radiates 9 kilowatt power. So transmitter power is 9 kilowatt, and with the carrier is unmodulated. And 10.125 kilowatt when carrier is modulated. So sorry. So what we have to do is when carrier is unmodulated means only carrier power is transmitted. So that is PC. When carrier is modulated means that is modulated power, that is 10.125 kilowatt, right? What is modulation index? So in AM we know PT is equal to PC into 1 plus MA squared by 2. MA is a modulation index, PT is 10.125 kW, PC is 9 into 10 power 3 kW, 1 plus MA squared by 2, kilowatt cancel. So MA squared is equal to 10.125 divided by 9 kilowatts, right? 9 minus 1 into 2, right? So this implies MA is equal to 0.5, that is equal to 50%. So option C is the correct answer. Next question, compounding is used in PCM. We know that it is used to increase SNR and reduce quantizing error. So another one important is reducing quantization error, right? So these are all when quantization error is reduced, noise is reduced, S by N reduced, SNR will be increased. Okay. Which of the following statement is correct with respect to IF? IF is nothing but intermediate frequency. So we must know something about intermediate frequency. When IF is high, if intermediate frequency is high, what will happen is it will lead to poor selectivity, right? So therefore, what will happen is poor adjacent channel rejection. Because the selection is poor, so it will also not reject adjacent channel, right? So poor adjacent channel rejection. Second one is high intermediate frequency will lead to tracking problem, right? So tracking problem of signals in the receiver. That is also another problem of high intermediate frequency. And the third problem is image frequency rejection will also become poor. Image frequency rejection is also poor. These are all the three important problems arise when we have high intermediate frequencies. Poor selectivity, tracking problem, and a poor image frequency rejection. So from that we can understand if IFSI tracking is improved is a wrong answer because tracking will be a problem. If intermediate frequency high, the receiver will have poor selectivity and poor sensitivity. That is a correct answer, right? So if IF is high, what will happen? The receiver will have a poor selectivity problem and poor sensitivity. That is some confusion. If IF is high, image rejection will be very bad. So if IF is low, sensitivity is poor, selectivity is poor, right? So that is also wrong. So option B is the correct answer, right? If IF is high, the receiver will have poor selectivity and poor adjacent channel rejection, right? If IF is low, selectivity is poor is wrong. Okay, next one, the maximum value of entropy is 1. Next, according to Shannon's theorem, the output at any source of rate R can be coded and transmitted over channel C when C must be greater than R, right? So C is nothing but channel capacity. Channel capacity must be greater than bit rate. Yes or no? Yes. If I want to if I want to allow a lorry through a road, the road must be lengthier than or bigger than the size of the lorry. If it is a narrow lane, then lorry cannot go like that. If I want to transmit the data, the channel must be greater than channel capacity must be greater. It must be able to accommodate the bit, so it must be greater than R. So C is greater than R. Okay, so next we will see TNEB 2018 question. See, just it's a wonderful question they are asking in every exam, so this is very important. Channel formula is C is equal to B log of base 2. Don't forget, in problem we have to use base 2 1 plus SNR, a signal to noise ratio. Sampling theorem is denoted as, so it's easy only. We know sampling theorem is given by Fs is greater than 2F max, right? So everything in terms of T they have written. So Fs is 1 by del T. Del T is the interval between the two samples that is greater than 2F max. Right, instead of F max they have substituted mu max, so it would be mu max. Right, so option A is the right answer. Next one, the NQPSK, the average probability of error in AWGN channel is PQPSK is equal to Q of root 2 EB by N naught. So like that you must know for ASK, FSK and PSK also, right? So probability of error is very, very important. Already I told in the TRB video, right? Okay. Next one, the bandwidth required for a modulating signal of frequency FM is 2 kilohertz frequency deviation del f is 10 kilohertz given by Curson's rule. Bandwidth for FM. As per Curson's rule, bandwidth is equal to 2 into del f plus FM. So 2 into del f is 10. This is 2. 12 into 224 kilohertz. So option D is the right answer. Next one, in PCM, the audio frequency is 6 kilohertz. What is the sampling rate? We know sampling rate is Fs is equal to 2F max. What is 2F max is 6 kilohertz they are given, so 6K, so that is equal to 12 kilohertz. So sampling rate is 12 kilohertz. Okay, next one. The power of an angle modulated wave PM or FM with amplitude by A squared by 2. Why in PM or FM? A is constant, that is amplitude doesn't vary. Only in AM modulation, amplitude is changed with respect to carrier wave, right? So, so what is the thing? Here amplitude is fixed, so its value is A squared by 2. If you find power by using the technique you learned in signals and system, how to find the power. So what we get is A squared by 2. Okay, next one, amplitude shift keying is not widely used because we know amplitude shift keying doesn't have constant envelope because amplitude is varying. Why? For 1 we have represented by some AC sin omega ct. For 0 is represented by 0. If you transmit 1 0 1 0, what will happen? Amplitude for 1 we have one signal, for 0 so 0 means 0. So the amplitude doesn't have a constant envelope. For 1010, it may be like this, right? So it doesn't have a constant envelope. So what will happen is it is more vulnerable to noise. It is not a complex. A's case is very simple one. So this is the wrong answer, right? So it requires high bandwidth. That is also wrong, right? It requires low bandwidth only, right? It doesn't require high transmitted power, right? So it requires very low transmitted power. So the correct answer is option B. Next question, the autocorrelation function of a white noise, right? So you see white noise will be having a spectrum like this, right? So F Sx of F, this is a constant. This is what white noise. So what is this? It is a power spectral density of white noise. If you take inverse Fourier transform, what you get is autocorrelation. So autocorrelation will be like this, Rxx of tau. It is an impulse function. So the autocorrelation of a white noise is delta function or impulse function. Similarly, if they ask what is the power spectral density of what you call delta function, you can say it is constant spectrum, right? So or you can say it is a uniform spectrum. They may ask like that also. Okay, fine. Next problem. Compute the Hamming distance between the two codes. Right? So what is the code word they have given? 1 0 1 1 0 1 0 1 1 1 0 0. So if you want to compute the Hamming distance, what you have to do is Hamming distance in how these two code words are, how many bits are different in these two code words. The number of different bits, the number of different bits between two code words is gives the Hamming distance, HD, Hamming distance. You see here how many bits are different. These two are different. One here code word 1, this code word 2, here 1 0, so this is the one difference, right? So it is 0 0, right? Here there is no difference, leave it. 1 1 no difference, 1 1 no difference, 0 0 no difference, 1 0 1 difference. So how many bits are differing? 2. So Hamming distance is 2. The number of different bits between two code words gives Hamming distance, right? So it is simply a number of difference between number of different bits between two code words. So the answer is option D. Okay. Next question. In a PAM system, we have 4 signals, right? Each are band limited to 5 kilohertz message. Okay. And sampled at twice the Nyquist rate. So Fs is 2 FM is the Nyquist rate, right? But here it is sampled at twice, 2 times the Nyquist rate, 2 into 2FM. That is a very, very important. So this word don't forget. The resulting PA samples are transmitted over a single channel after TDM. What is the minimum transmission bandwidth of the channel? So first we have to find what is the Nyquist sampling frequency that will give the bandwidth of the channel. So here what is FM? FM is 5 kilohertz. So Fs is equal to 2 into 2 into okay, right? So 5 kilohertz. 2 into 2 into 5, so it is for 10 into 2 20. It is for one signal, but how many signals we have here? We have 4 signals, so that must be multiplied by, for one signal sampling rate is 20. For 4 signals F is equal to 20 into 4, 80 kilohertz. So we are having a sampling rate of 80 kilohertz. This must be transmitted over a channel. This must be transmitted. The PM samples are transmitted over a channel. So what is the frequency? 80 kilohertz. So what is the minimum bandwidth I require? Minimum I need 80 kilohertz. Right? So don't put 40 and don't put 20 also. Right? That is very important. Next one. A 400 watts carrier is amplitude modulated to a depth. So PC carrier frequency is 400 watts. Depth of the modulation is 100%, means 100 by 100, 1. How much power saving achieved by SSB-SC compared to AAM DSP and AAM DSB-SC AAM full carrier? So first we find how much power spent by the or dissipated by the SSB. So power dissipated or power transmitted by the SSB is given by MA squared PC by 4. MA is 1 into 400 by 4 is 100 watts. Right? Power transmitted by DSP is MA squared PC by 2. So 1 into 400, MA is 1, PC is, so it is 200 watts. Okay. Power transmitted by AM is PC into, right, 1 plus MA squared C by 2. PC is 400 into 1 plus MA squared by 2, 1.5, that is 600 watts. Right? So what is the question? Power saving by SSB compared to this. So power transmitted by SSB is 100 watts. Power transmitted by AM is 600 watts. So compared to AM, power saved by SSB over AM is, this is 600 watts, this is 500 watts. It has spent only 100 watts. It has spent 600 watts. So how much power is saved? 500 watts. Similarly, power saved by SSB compared to DSB is, this spent 200 watts, SSB spent 100 watts. So how much power is saved? 100 watts. So the answer is power saved compared to full AM with full carrier is 500 watts. It has saved. Compared to SSB, it has saved 100 watts. So option B is the correct answer. Next one, in angle modulated signal, if an angle modulated signal is given by this, FA of t is equal to cos of 2 into 10 power 8 by t plus 75 sine 2 into 10 power 8 by t. What is the peak frequency deviation? That is, they ask about del f, frequency deviation. So now we compare with the general equation of angle modulated signal. So general equation of angle modulated signal is given by FA of P is equal to cos omega CT plus KF AM by FM sin omega MT. So KF AM is given by del F. So I can write del F by this two collectively called del F. This is a general equation. So if you compare both, del F by Fm, del F by Fm is equal to 75. You compare these two, omega m. Omega m is nothing but 2 pi Fm is equal to 2 into 10 power 8 pi. This implies Fm is equal to 10 power 8. So from this, you can understand del F is equal to 75 into 10 power 8. So 7500 megahertz. Right? So the answer is 7500 megahertz. It's not there. So you can put anything. The exact answer is 7500 megahertz. So it may be here also or here also. So we put it as per the which one is closer to that. This one is closer. It is simply 7500 hertz. It is 70,000 or some 75,000 hertz. So it is somewhat closer. So you put 7,000. That one is the answer. But the exact answer is 7,500 megahertz. Right? Okay. Sorry. Right. Next question is a PAM signal may be demodulated by using, that is a direct question. It is low pass filter followed by equalizer. Right. So well-known direct question. We must know about how PAM is modulated and demodulated, like that BPM, PDM, and PWM also. And next question is a 200 watt carrier. So carrier power is 200 watts. Modulated to a depth of 60%. 60% means 60 by 100, so it is 0.6. What is the total power modulator? So simply PT is equal to PC into total power density modulator is PT. This is the formula. PC is 200. 1 plus 0.65 by 2, that is equal to 236 watts. So option D is the correct answer. Next question, the technique involving in frequency translation is, it's direct question, modulation. Amplification is talking about, it is bothering about only amplitude. So this is the wrong answer. Filtering means it is allowing or stopping the frequency. So this is also wrong answer. Clamping means it is raising the signal, right? Rising up or rising down. So it is not at all also transfer. Modulation is a frequency translation. How we know that if you are having a cos omega mt as message, cos omega ct as carrier, what happens? We get the AM signal as AC cos omega t plus MEAC by 2 cos omega c minus omega mt plus MEVC by 2 cos omega c plus omega mt. Right? Omega c and omega m is translated. We know the AM signal as this is omega c, this is omega c plus omega m, omega c. We have three band, upper side band, lower side band, right? So omega 1, omega c are transferred to these two bands. This frequency is translated to these frequencies. So that's why modulation, the main aim of modulation is frequency translation only. Very, very important, right? We are translating from low frequency to high frequency. Next one, choose the correct answer related to delta modulation, right? So incorrect answer, not correct answer. So delta modulation is 1-bit modulation, that is the right answer. Delta modulation transmits derivative of m of t, that is also right answer. Delta modulation uses first order predictor, yes, that is the correct answer. Delta modulation is unsuitable for television signal, that is the wrong answer, right? So option D is a correct answer, right? So These are all right answer only, right? We are transmitting the derivative of m of t only in delta modulation, right? It is the first order predictor. Okay, next question is, if the minimum possible length of a coding scheme are minimum possible length and average length. So minimum possible length is 2.418. Average length is 2.45. Right? What is coding efficiency and redundancy? Coding efficiency eta is given by L minimum by L average. L minimum and L average value we know. If you simplify, what you get is 0.986. What is redundancy? Redundancy is equal to 1 minus eta, so it is 0.014. So option D is a correct answer. We must remember, you see, R plus N is equal to 1 from this equation. R plus eta is equal to 1. That means redundancy plus efficiency is equal to 1. So redundancy plus efficiency is equal to 1 means you add these two, it is greater than 1. So this is wrong answer. If you add these two, this is also wrong answer because it is greater than 1. Summation is greater than 1. But only these two are mostly correct answer. So if this is also greater than 1, you don't need to calculate, directly you can write the answer. Okay. Next one. Okay, a 10 kilowatt carrier. So they have given carrier power is 10 kilowatt modulated to a depth of 100%. 100% means 1 MA, 100 by 100, 1. What is the power transmitted? Right, this simple problem. So it is equal to PT is equal to 10 into 1 plus 1 by 1. Right, so it is 2. 1 ma squared by 2, 1 plus ma squared by 2, 1 plus, so it is 10 into 1.5, that is 15 kilowatts. Because formula is PT is equal to PC 1 plus ma squared by 2. So the answer is option C. Next question, FM wave is represented by the equation, this one. What is the modulating frequency and the frequency deviation? So first they write FM wave 12 sine 6 into 10 power 60, 10 power 8, 10 power 8t plus 6 into cos 1250t. So we have to compare with the general equation of FM. XFM is given by, what is the general equation? A cos omega ct plus del f by fm, del f by fm, that is beta, cos sine omega mt or cos omega mt, that is not a problem. I write sine omega mt. Right, from this you can see, compare both the equation, omega m is equal to 1250. This implies fm is equal to 1250 divided by 2 pi, because 2 pi fm is omega m. So fm will be 199 hertz. Right? Similarly, we know, compare del f by fm is equal to 6. Del f by fm is equal to 6. This implies del f is equal to 6 into fm. Fm is 199. That is equal to 1194. So the answer is 199 and 1194 hertz. Simple answer. Right? And the midband frequency of IF section is, and IF bandwidth of AM and FM. It's a direct question. It is a standard value. For AM, the value of IF is 455 kilohertz. 455 kilohertz is nothing but 0.455 megahertz, because everything they have given in megahertz. So option C is the correct answer, direct question. And IF frequency is this one. Bandwidth is 10.7 megahertz, right? Similarly for FM, it is IF intermediate frequency is 10 kilohertz. at intermediate frequency bandwidth is 200 kilohertz, right? So this is very important. Okay, 4.5, 4.55, sorry, 0.455, 10.7, 10, 200, right? Next question, match the following. Detection of periodic signal in noise, right? So it is comparing signal and noise, so it is a cross correlation. So 4A, right? What is autocorrelation and cross correlation? Autocorrelation did a compare similarity between same signals. One signal is at present, another signal is shifted. Cross correlation function is similarity, measurement of similarity between two signals, two different signals, right? So here we are finding the signal and signal in noise. So we are finding, we know signal and noise will be different. So we want to find the different similarity between signal and noise. So 2, so it is cross correlation. Recovery of band limiter signal from its uniformly sampled value. That is nothing but Nyquist rate, right? Why Nyquist rate is defined to, we are converting a continuous time signal into discrete time signal, right? And we can get back the original signal later by if fs is greater than 2f max. That's what sampling theorem. Otherwise, we cannot recover, right? Final quantization of signals is achieved and it will increase the bandwidth. So it is C. Delta modulation has slope over distortion. So option A is the correct answer, right? Quantization, final quantization means what will happen? You are increasing the number of levels, right? Okay. Next one, consider the following drawbacks. Which of the following are related to delta modulation? We know in delta modulation we have slope over distortion and granular noise. So 1 and 3 are correct answer. We don't have serration noise, quantization noise, right? Okay. In PCM, 5-bit encoder is used, right? So what is the n value? N is equal to 5, and each represents 1 volt. What is the range of encoder? So by using n 5 bits, how many levels we can represent? We can represent 2m levels. So it is 32 levels we can represent. 32 level means 0 to 31. Each level is represented by 1 volt. So how much volt, how many voltage we can represent? 0 to 31 volt. So answer is option B. Right? Next question. In a communication system, noise is likely to affect the channel in the channel, right? So in channel, the noise system is mostly affected, right? In a transmitter also there may be noise, but channel contributes more. Which of the following statement, what do you call, is true, right? So out of this, the direct question, which is option C, noise in mixer is caused by inadequate frequency rejection, right? So that is the answer, right? So option C is correct, right? Others are wrong, right? So flicker noise is not at all called demodulation noise. Random noise power is inversely proportional. There is no relation. Yeah, random voltage across a resistance cannot be calculated. Yes, of course it can be calculated. Okay, next, in a low-level AM system, amplifiers following the modulator stage must be linear device. That is very important, right? It should be a linear amplifier. Okay. To provide two or more voice circuits with the same carrier, it is necessary to use ISB, right? Next, one of the following cannot be used to remove the unwanted sideband in SSB, right? So what is that is balanced modulator. We can use a phase shift method or frequency shift method or filter to remove one sideband. So balanced modulator is the only thing cannot be used, right? So these three can be used, right? Another method is frequency shift method is also there, but balanced modulator cannot be used to remove unwanted sideband. Right? So unwanted sideband means removing the frequency. Filter can remove, phase shift method can remove. Third method is another one method. So we cannot use balance modulator. Indicate which of the following is not an advantage of FM over AM. FM has better noise immunity, of course true. They ask not advantage, it is advantage. The transmitted power is more useful, that is also true. Less modulating power is required compared to AM. Why? Because in FM, A is not, amplitude is not changed. But FM has more bandwidth, so this is a wrong answer. Lower bandwidth is required. No, FM requires more bandwidth compared to AM. So option B is a right answer. Right? They ask not. Please read the question properly. To prevent overloading of the last IF amplifier in a receiver, right? One should use variable sensitivity. Very, very important point. Next question. A carrier is simultaneously modulated by two sine waves with a modulation index. One is having a modulation index of 0.3, another one has modulation index of 0.4. Total modulation, if you are having two modulation or n modulation index is m1 squared, m2 squared up to mn squared. So here we have 2, so modulation index is 0.3 square plus 0.4 square. Total modulation is 0.5. So the answer is 0.5. Right? And the next question is high frequency waves. They are capable of using for long distance communication, right? So answer C is the right answer. Next, in a pulse duration modulation, the magnitude of all the pulse remain. Here, the modulation is changing the duration of the pulse. So magnitude of the pulse remains constant. Only duration should be changed, right? But the duration of the pulse varies. So the magnitude should be constant. So option C is the right answer, right? So that's all about this session. I hope you understand every question clearly. If you have any doubt, please ask me in comment section. I will clarify. So there I have in TRB questions I have posted 83 questions here on 43. So 126 questions. If you see all the questions, we can see some correlation, the repeated questions. So give importance for that. All the best. Thank you.